Hello dear students, welcome back. In a previous video we have discussed that change of variable using the Jacobian transformation and the double integration, how it will work and how we can solve the double integration. But now we are going to discuss the same thing but using the polar coordinate. That means we are changing of variable from the Cartesian coordinate to the polar coordinates. So let us see first. Change of variable from Cartesian to polar coordinate. Suppose you have given that xy plane is there, but when we transform to r and theta by assuming that x is equal r cos theta and y is equal r sin theta. Double integration f of xy dx dy is equal double integration f of r cos theta r sin theta when x is replaced by r cos theta and y is replaced by r sin theta. But here Jacobian j into dr d theta. But already it is said that whenever you transform xy to r in theta coordinate, so in that case you have to determine that is the Jacobian transformation. So in that case what we must have, x and y, it must be in terms of r in theta, so that we can determine that it's a partial derivative of x with respect to r and theta, similarly for y r and y theta. So these are the partial derivative with respect to r and theta, and that case you can determine it, and whenever you simplify that, and what you are going to get. Suppose that x is equal this one, suppose I want to partial derivative with respect to r, so what I will get, that is the only cos theta. When I consider partial derivative of x with respect to theta, so it will be minus r sin theta, and that is we have. And same for y with respect to partial derivative with respect to r, so what I will get, that is sin theta. But when I do partial derivative with respect to theta, so I will get that is the r cos theta. But when you take it as determinant, so you will get r cos square theta plus sin square theta in the bracket. So cos square theta plus sin square theta is nothing but 1, and when you simplify, so you will get r. That means Jacobian j is nothing but r dr d theta. So we will keep in mind that whenever we use the polar coordinate and when we transform xy plane to the polar coordinate, so what we will do, we will consider dx dy is same as dy, dx is same as dA, and that will be changed by r into dr d theta when we use the polar coordinate. So this is what our Jacobian transformation j. So let us evaluate double integration. First integration, that is 0 to n, then after integration, that is 0 to under root a square minus x square plus y square dy dx by changing into the polar coordinate. But if it is not given that the changing into polar coordinate, still you can solve this example using the simple method. But when you use the polar coordinate, so it is going to be very simple to evaluate this double integration. But in this particular question, we are using the changing into the polar coordinate. That means we need to consider x is equal r cos theta and y is equal, that is the r sin theta. But here first let us understand what are the limit it is given that. So first limit is given for y is equal, that is 0 to under root a square minus x square. But when we take square on the both the sides, so what I am just going to get, y square is equal a square minus x square. But when we consider outer limit, so it is for what exactly, x is equal 0 to x is equal a. But when we draw the graph, so what I can consider, so this is our first x square plus y square is equal a square, that means a radius circle centered at origin. So this is our circle centered at origin, but the radius is nothing but a. But when you consider y is equal 0, so this is what x axis and this is the y axis, and this is what exactly y is equal 0 line, that is our x axis. And another given is that the x is equal a. So x is equal a, that means this is what exactly our line x is equal a, because radius is nothing but a, so our point will be, this point will be a comma 0, this will be minus a comma 0, this point will be 0 comma a, and last here it will be 0 comma minus a. So here first limit x is equal 0 to x is equal 0, that means y axis, and x is equal 0 to x is equal a. So we are going to consider only first quadrant. Another says y is equal 0 to y is equal something, that means it is considered strip which parallel to what exactly y axis. So we can say we want to concentrate on the first quadrant. So in that case, what I have to do, I have to find the limit for r as well as theta. But when you consider limit for r, so whenever we consider the radius, so it is starting from where to where? It will be always from 0 to, and radius is nothing but a. But for what rotation we can covered only first quadrant, so it is clear that when I start from theta is equal 0, so this is what exactly theta is equal 0, and this is what exactly theta is equal pi by 2. So when I rotate to start theta is equal 0 to pi by 2, so it is going to be the covered first quadrant. So therefore limit for theta will be, that is 0 to pi by 2. So in that case, now it is clear that limit for r is equal, that is 0 to a, and theta is equal, that is 0 to pi by 2, and x square plus y square, and that can be written using this one, so it will be the r square. So I can say our integration becomes, so first limit r is equal, that is 0 to a, theta is equal, that is 0 to pi by 2, and here it is given that x square plus y square, but x square plus y square is what? That is r square cos square theta plus sin square theta. But when you see dy dx, but as usual dy dx will be what? That is the Jacobian j dr d theta. But already we have discussed that whenever you consider x is equal r cos theta and y is equal r sin theta, so Jacobian j is nothing but r, so you will get r dr d theta, and in that case I can write that is r dr d theta. But here cos square plus sin square theta is nothing but only 1, so you will get that is the only r raised to cube dr and then d theta. But when you integrate with respect to r, so what you are going to get? So you can say r raised to power 4 divided by 4 over where to where? That is 0 to a and then d theta. When you put the limit for r is equal a, so what you are going to get? A raised to 4 divided by 4 and r is equal 0, so it will be 0, and then after d theta, so a raised to 4 divided by 4 is nothing but constant quantity, but when you integrate with respect to theta, so you will get theta over where to where? That is 0 to pi by 2, so you will get a raised to 4 in pi divided by what? That is the 4 into 2, that is 8. So let us consider another question. That is really very nice question, but when it is very easy, but when we use the polar coordinate. So the target is what? First given limits are. So given limits are, so first limit says x is equal y. I'm just writing this one, x is equal y to x is equal a, and another limit is what? Exactly y is equal, that is 0 to y is equal a. But when we draw the graph, so what it will be? So you can see that this is the x is equal y. Another, that is x is equal a. So if I suppose to assume that x is equal a, so this is going to be x is equal a. So your intersection point will be what? So you can say that is a comma a. Y is equal 0, so this is our x axis, and x axis is nothing but y is equal 0. And y is equal a, that means we are considering this is the line, that is the y is equal, that is the a. So which is the bounded region from this figure? So first limit is considered for x, that means it is considered strip which are parallel to x axis. So now you can verify that left hand side is nothing but x is equal y, and that is we have, and top is nothing but x is equal a. But what range you can consider? So y is equal 0, I can start until what? That is y is equal a, and therefore it is given. But now we are transforming to the polar coordinate. So by using polar coordinate, so what I can assume that, so which are the polar coordinate? That is x is equal r cos theta and y is equal r sin theta. So whenever it is required, so dx dy will be used as r dr d theta, and that is, you know that this is nothing but our Jacobian j, and that you can determine. But now we need to consider, that is the limit. How we can determine the limit? So here, so whenever I'm just going to consider another figure, then it will be very clear. So I'm just going to focus only this portion. So for this is what exactly where x is equal y. So I have to consider that the radius. So radius always we are going to considering from the origin. So r is equal, that is 0 to r is equal, and this is the part of what x is exactly x is equal. So we can say here x is equal, that is a, that is given, but x is nothing but r cos theta. So what I'm just going to get, r is nothing but that is a divided by cos theta, and that is what a sec theta. So therefore we have the limit for r will be, so therefore limit for r, that is going to be what, that is 0 to a sec theta. Another limit is what, that is from where to where, so that I can get the angle. So I can say this is our theta is equal, that is the 0. But what rotation should be there, so that I will cover only this one portion. So theta is nothing but this is the pi by 2, but we want here x is equal line, y is line is given. So I'm just assuming that x is equal y. So x is nothing but r cos theta and y is nothing but r sin theta. So it is clear that r will be eliminated, and you will get that is the cos theta is equal sin theta, and this is only possible when we assume that theta is equal, that is the pi by 4. So now it is clear that I have to rotate theta from where to where. So theta is starting from that is 0 to pi by 4. So it will cover only this one region, and r is nothing but that is 0 to what exactly a sec theta. So now you can say that this is r is equal, that is 0, and this is r is equal, this line is nothing but a sec theta. But when we rotate theta is equal 0 to this line is what exactly theta is equal, that is the pi by 4. So in that case you will cover only this one region. So our double integration transforming into polar coordinate, this is the given, but it is first radius r is equal, that is 0 to a sec theta, and theta is equal, that is 0 to pi by 4, and x is nothing but r cos theta, and x square plus y square, that will be the r square, and dx dy is nothing but r dr d theta. But when you simplify, so this is going to be the cancel out, and you are left with only cos theta dr d theta. But when you integrate first with respect to r, so what you are going to get, this is cos theta is nothing but constant. So r from where to where, that is 0 to a sec theta, and then d theta. But when you put the upper limit and then after the lower limit, so what you are going to get, a sec theta into cos theta, and these are the inverse of each other, so it will be the 1, and you are left with only a, but a is a constant, so we can take outside from this integration and then integrate, that is 0 to pi by 4 d theta. But when you integrate with respect to theta, so you will get only theta from 0 to pi by 4, and what when we put the limit, so you will get a into pi by 4. So the answer will be pi times a divided by 4. So that will be the final. Thank you.